These laptops make study much easier. Oh no, it's almost time for the group meeting. So, we're late. What are you doing?
Oh, I'm studying.
Studying while laughing?
Okay, we're late. Let's go.
Assalamualaikum warahmatullahi wabarakatuh. We are students from section 803 and our report is about the daily screen time of CFS students. Nowadays, it's very common to see people glued to the devices and it's an understandable concern when it's students that are relying on the devices excessively. The aim of the study is to determine the average hours of daily screen time of CFS students while also determining the effects that the device may have on their academic performance. These can be obtained through collection of data via Google Forms.
The sampling technique used by our report is non-probability sampling, or more specifically, convenience sampling. The population is students of the Center of IIUM Studies. We will be collecting data from both male and female students to possibly compare data between the two. Respondents are chosen randomly according to those who filled the form via the available channels. From the data collected, we can conduct a descriptive analysis by finding a central tendencies such as the mean, median, and standard deviation.
Before analyzing the data, we first constructed this frequency table. We decided to use 6 classes, so the class interval is calculated by dividing the range by the number of classes. That gives us 23 divided by 6, which is approximately 3.8, and we rounded it up to 4 hours for convenience. Using this class width, we then set the class limits such as 0 to 3 hours, 4 to 7 hours, 8 to 11 hours, and so on. To make sure there is no overlap between these groups, we determine the class boundaries, which clearly separate one class from another. For each class, we calculated the midpoint by averaging the lower and upper class limits. For example, for the 4 to 7 hours class, the midpoint is 5.5 hours. The frequency is obtained by counting how many students fall into each class. For instance, 40 students fall into the 4 to 7 hours category. The cumulative frequency is then calculated by adding each frequency step by step, and by the final class, the cumulative frequency reaches 88, which represents the total number of respondents. This table is important in calculating central tendencies.
Up here. Actually, let me just come down. When we calculate the descriptive statistics, we use this formula. We find the average screen time is about 8.2 hours. The median is 7.6 hours, meaning half of the students spend more than that and half less. The mode or the most common screen time is around 6.9 hours. The standard deviation calculated is about 3.7 hours, which is fairly large compared to the mean. This tells us there is a wide spread in the data. While most students spend between 4 and 11 hours on screens daily, there is significant variation. Some use screens much more, which pulls the average up. Now, take a look at the histogram we've made based on this table. As you can see, the histogram visualizes how many students in each time category per day. The x-axis shows screen time in hours, broken down into 6 different classes of 4 hours each, starting from 0 up to 23 hours. The y-axis shows the number of students in each classes. The tallest bar is 4 and 7 hours, with 40 students fit in that range. This fits in to the mode that we have calculated earlier. That means nearly half of the surveyed students spend a moderate amount of time on the screen each day. For the first bar, only 3 students reported less than 4 hours of screen time per day. At the other end, we can see smaller group, 4 students spend between 16 and 19 hours, and 1 student only spends between 20 and 23 hours. This tells us that while most students spend around 4 to 11 hours of screen time, there are also some who use screens so much that we are considered to be the outliers.
That's exactly like drama I watched last night.
So entertaining.
Bye.
Speaking of entertainment, we also ask students where they spend most of their time on their devices. As shown in the graph beside me, only 7 students in our survey said they mainly use education apps, which is a very small number. In contrast, the large blue bar shows that 81 students spend most of their time on entertainment apps. This means that more than half of the students we surveyed are using their devices for entertainment rather than for work or study. This shows that for most CFS students, smartphones are seen as a source of distraction first and a learning tool second. We also asked respondents which app they use the most. Based on the first chart, the most commonly used educational applications are generative AI tools. In contrast, traditional platforms like Microsoft or Google application are the least used with 12.5% of respondents voting for it. Now, if we look at the second chart, entertainment-based applications clearly take up most of the students' screen time, with social media platform a percentage of 80.7%. Meanwhile, creativity-based applications such as Procreate and iDispaint are very uncommon, with only 1.2% respondents voting for it.
Wait a second. Why are we doing this K-drama cutscene again? It's my turn. We also have a few lighter skill questions to better understand how students feel about the device usage. I will be explaining question 4 of the questionnaire. My device usage improves my productivity. This is the bar graph representing the results. We can see that mode and median of our data, as shown by these calculations, is 2, neutral. We can also see the least common answer is 0, actually meaning a small percentage of students feel it negatively affects their productivity. From all these findings, it's safe to say a majority of students feel 50-50 regarding this question. The device doesn't improve nor badly affect their productivity at all.
For this question, students were asked whether their device or screen usage improved their grades. When we analyze the data, the mean score is 2.43. This indicates an overall tendency towards agreement. The median response is agree, meaning at least half of the respondents believe their device usage has positive effect on their grades. Similarly, the mood is also agree, making it the most frequently selected response.
Last but not least is question 6, where respondents were asked whether their use of device helps them become better students. So the bar chart provides us a clear visual representation of this distribution. The chart shows the highest frequency occur at skill 3 and 4, which correspond to agree and strongly agree. In contrast, the responses for strongly disagree and disagree are relatively low, indicating that only a small amount of respondents feel that device usage negatively affect their learning. So, to support this observation, the mean and median and also the mode were calculated. The mean score is 2.53, indicating a general tendency towards agreement. Both the median and mode are 3, which correspond to agree.